everybody. I'm going to go over the second deliverable from last week, week 31, the mole. A lot of you did a great job on the deliverable and are starting to understand the concept. But some of you messaged me and said you were confused. Maybe you're struggling to make it through the lessons. And so I'm actually going to go over, just by video, the deliverable to help you hopefully understand this foundational concept that we are going to use for the rest of the semester. So this is practice 4.8. It was due on Friday, but I recommend you turn it in still if you haven't turned it in yet. I'm going to go over a few of the problems. So you must show your work to get credit for this because I've given the answers here on this document. So number one is, what is Avogadro's number? And I kind of wrote this here. This is more than you needed to actually respond to, but a summary is, Avogadro's number is a conversion factor that helps us measure how many particles or atoms or molecules are in a given amount of a substance. We will use it to help us calculate amounts of reactants needed in a reaction or amounts of products produced in a reaction over the coming weeks. The mole conversion factor, otherwise known as Avogadro's number, is 1 mole of anything is equal to 6.02 times 10 to the 23rd things. Usually particles or atoms or molecules, depending on what we're looking at. You can also round this to 6 if you don't have a calculator, 6 times 10 to the 23rd. I'm going to start with the problem number 2. Problem number 2 says, how many atoms are in 4 moles of hydrogen gas? So 4 moles of H2. I have moles on top here. It was given in the problem, and it's asking for atoms. So 4 moles of hydrogen gas, we need to convert it to atoms using our conversion factor. So I know that I'm going to have to put 1 mole, it's always 1 mole, using the conversion factor, for every 6.02 times 10 to the 23rd atoms. These will cancel, notice, okay? And then you'll have 4, and you'll multiply it by 6.02, the coefficient, and we'll add 10 to the 23rd on the end. So we're going to get 24.08 times 10 to the 23rd atoms of H2. Now, this will be okay to leave it like this. You would still get credit. However, if you are aiming for the level 4, this is not appropriate scientific notation. Scientific notation is only supposed to have 1 digit next to the decimal. So we actually should move this to become 2.408. I just made that number look smaller, and I moved it left, which means my exponent has to become bigger to balance that out so that they're the same number. 10 to the 24th atoms is actually the appropriate way to do this, to show the answer, okay? So you can pause if you need to look at that, pause the video. All right, I'm gonna do number 3. A number of people had questions about number 3. Number 3 is talking about candle wax, and it says how many moles are combusted if 1.5 times 10 to the 23rd particles of candle wax react completely. So here's that equation. We're going to start using equations coming up soon, but right now I'm giving you the real basics. Those of you that are not doing the full conversion factor method, you're going to start to struggle as this gets more complicated. So please learn this. Hopefully you saw why atoms shouldn't go on the bottom, because it wouldn't have canceled. Now watch this one. So this time number 3 gave us 1.5 times 10 to the 23rd particles of wax, and it's asking us for moles. So again, it can be 6.02 times 10 to the 23rd particles or atoms, molecules, whatever the problem gives you, just really tiny things, right? So particles, and it's asking us to convert to moles. So I'm going to use the same conversion factor, of course, always, and I'm going to put 6, I'm going to round it to be easier, 6 times 10 to the 23rd particles. And you can substitute particles or atoms or molecules depending on the problem for every 1 mole. Notice this time I actually flipped the conversion factor. Why? Because I need to be able to cancel my particles. So in this case, we multiply across, nothing goes below. Please don't put weird numbers here. It's really like over a hidden 1, but please, you don't even need to show that. You multiply the numerators, so that becomes 1.5 times 10 to the 23rd, divide by 6 times 10 to the 23rd. notice, okay, we stay on the denominator. Okay, 10 to the 23rd, remember when we divide scientific notation, you subtract. 23 minus 23 is 0, or you can just see that they cancel each other. So we get 1.5 divided by 6, if you do that by hand or in a calculator, is 0.25. Now what are my units? Please don't put particles. 0.25 particles? How could you possibly have 0.25 particles? Particles are so small, and we should have exponent on the end if it's a particle. It's moles, okay? We got left with moles, so our answer is moles of wax. Box that. Okay, the rest are the same as these two types of problems, okay? Message me if you need any more help. I taught a lot of Zoom lessons last week. I didn't see a number of you, so I highly recommend you check in. Okay, bye.